Okay, so for the warm-up, instead of letting you go off and try the warm-up on your own, what we're going to do is do this first question together, except I'm going to do it a deliberate way so that we can discover something and then use it in B and C. So what we're going to do is we're going to solve for y here. So this is just a plain old logarithm. You could actually maybe even look at it and see what the answer is. So this is asking what exponent do I put on base 3 to get 243? And it turns out there is a relatively easy number to find. So you can test it. You can try 3 to the power of 3. No, that's too small. 3 to the power of 7. No, that's too big. And keep narrowing it down. And it turns out that the answer is 5. Okay, so 5 is the exponent that you would put on base 3 to get 243. We can see it a little more clearly when we write this as an exponential. So the base is 3, the exponent is y, and the answer is 243. So we could do a common base here and see that the answer is 5. I'm going to actually apply yesterday's knowledge to this. It would be a bit of an overkill, but it's good to see that yesterday's strategy will work today as well. And that's by taking the log of both sides. So watch what happens when I take the log of both sides. Bring the y down, gets us access to that y. And now since it's y times log 3, I can divide both sides by log 3. And I get y equals log 243 over log 3. So that's the exact answer, and I bet you if you punch, actually I know, when you punch this in your calculator, you're going to get that the answer is exactly 5. So why am I pointing this out? Well, I'm pointing this out because this is showing you a possible way that you can use a calculator to answer any logarithmic equation. Before, the only ones that our calculator would work for is the common log, okay, those with base 10, because that's the only button that we have on our calculator. So if we notice the relationship here between the question, it suggests a way that we can find the log of any base by converting it to a common log. And you'll notice here that it turns out that the answer is, when you're asked to find log 243 base 3, is you can actually find it by taking the log of the answer, 243, and dividing it by the log of 3. This is going to happen every single time. So that's a way to evaluate a log and go straight from here using your calculator to get an answer of 5. Of course, it'd be handy when the answer is not as obvious as it is 5. So let's try and use this, go straight to it, and try and use it to answer B and C. So you notice we have log 50 base 3. Well, according to this pattern then, this can be rewritten as the common log of 50 over the common log of 3. Punch that into your calculator and you'll get the answer right away, and we'll go to 4 decimal places again, 5609. So it turns out when I'm asking what exponent do I put on 50 to get base 3, that exponent is 3.5609. And that'll get us a 50, or at least pretty close to a 50 if we round. So this is a way to calculate logarithms other than the common log base 10. So how can we use this to answer C? Well, remember, we can take this 2, and since it's being multiplied, it can come back and go up into the exponent. So this will go into 18 squared. So 18 squared is 324. And so now if we actually want to evaluate that on our calculator, we do the common log of 324 over the common log of 4. Punch that in our calculator. That's the exact answer there, and punch that into our calculator, and we'd get the answer is about 4.1699. So I wanted that to be our starting point as a way to find the, to evaluate other logarithms other than just the common log of base 10. You can actually find that out. That'll be helpful for what we're doing today. So what are we doing today? Well, we're going to solve logarithmic equations. So I'll give you a second to copy that down. And as you do, I'm going to talk about how today's lesson is different than yesterday's. Yesterday, we were solving exponential equations. So the equations we started off with had x up in the exponent. And we used logarithm to solve exponential equations. So logarithms happen to come along and appear, but we were started with exponential equations and we were trying to solve them. Today, we're solving logarithmic equations. So these are equations that already have logs in them. And the x's are going to be in different spots. Yesterday, the x was just up in the exponent. That's what makes it an exponential equation. But these ones, the x's are in different spots. Now, we're going to use the laws of logarithms, use the fact that logs are exponents, to go off and solve these. So first things first, in example 1a, similar to linear equations, to solve logarithmic equations, one strategy is to get the term that has x in it by itself. So you know how if we had, you don't have to write this down, but if we had like 2x plus 4 equals 10, the first thing we would do is not isolate for x yet, but we'd isolate for this term. So we go 2x and we take this and bring it over here and make it 6. Then you would go off and try and isolate the x. Same strategy here. So let's put the term that has the x in it by itself. So that is this one, the log x base 2. This over here is log 6 base 2. And this one's going to have to move across, so it becomes a plus log 2 base 3. By isolating the term with x in it, we have on the right-hand side created an addition of logarithms who have the same base. So the product law tells us when we have, this is from a couple days ago, and we saw it yesterday, when you have two logs with the same base and those logs are being added, you can combine them and multiply to answers. So this can combine into a single log of base 2, 6 times 3. So of course, 6 times 3 is 18. And we're now down to this. And now we're sitting there looking and it says, give me the x value to make it equal to this. Well, since they have the same log or the same base, all we need to do is compare the answers. So this is very similar to that last step when we did common base. You got the common base, you could say, okay, since they have the same base, the only way this is going to work is if you just look at the exponents. Well, here it's a similar idea. Since they have a common log, we can ignore it and look at just the answers. So I'm going to put therefore again, so it's important. So the only way this can work is if x is equal to 18. And we've solved the logarithmic equation. So this is the strategy I use most often. I do want to point out though that you don't necessarily have to use this strategy. So I'm going to redo this question again, but I'm just going to show you another way you could have done it. So another way you could have done this is looked at the left-hand side and said, hey, they both are log 2, and I am subtracting So the division law for logarithms tells me that if I have the same log and I'm subtracting, I can break the answers together and divide. So this can go combine into a single log, and it would be x divided by 3. Now, we're in the same boat that we were at the end of the other one. This is log base 2, this is log base 2, and as a result I can ignore them and look just at the answers. So therefore x over 3 equals 6. Now I have a quick little algebra to solve. Bring this 3 up top, and it becomes 6 times 3, and the answer is 18. So that strategy works as well. So I don't mind if you use this strategy and try and convert it to a single log and get common logs on both sides so you can ignore them. Or if you want to isolate for the term with x, get common logs and get your answer. Both will work. Now, let's apply it for example B. Right now, it looks like we're pretty close to being already in common logs. This has a log base 3. This has a log base 3. The only catch is this 2. And I want log base 3 by itself. Well, I can use my rule, and I've done this a couple times. I did it in the warm-up as well. I'll bring in that 2 up there. So this can change to log x base 3. That 2 can go up top, so it's log base 3 of 4 squared. Of course, 4 squared is 16. And now we're set. The common log of base 3 and a common log of base 3. That means we can ignore the logs and say the only way this will equal is if x equals 16. And I have my answer. So this is where the practice the last couple of days of being able to simplify logarithmic equations and all that sort of stuff, and using and understanding all the laws that we did earlier in the week will be very helpful, because this is where we're actually applying it.